So this is our paper 2, and the question number 1 in paper 2 says, is a coulomb of charge greater or the charge of an electron? So we know that one electronic charge, that is equals to 1.6 into 10 raised to minus 19 coulomb, right? So that is 10 to the power negative, okay? So it is much smaller than 1 coulomb. In 1 coulomb we have 6 into 10 raised to 18 electrons, a lot of electrons, and all of them are contributing that much charge to give it 1 coulomb. So which one is greater? Yeah, 1 coulomb of charge is greater than the charge of an electron. Let's move to question number 2. Question number 2 says, the amount of negative charge present in 63 gram of HNO3. So 63 grams of HNO3 means, first of all, we have to find the number of molecules in 63 grams of HNO3. First, let's find the molecular mass of HNO3. So HNO3 molecular mass, okay, which is, what is the molecular mass of hydrogen? 1, nitrogen 14, and oxygen 16, but there are 3 molecules, so 16 into 3. So this will give us 15 plus 48. 16 3 is a 48. Now this will give us 8 5 13, 1 4 1 5 63. So the molecular mass is, okay, so let me write here, molecular mass of HNO3 is 63 gram. Then after once we have calculated molecular mass, what we have to do? We have to find the number of moles. So number of moles, as we remember, number of moles is equals to given mass over molecular mass. What is given mass here? Given mass here is 63 gram as per the question, you can see here. And what is the molecular mass? That too we got as 63. So number of moles here is 1. We have 1 mole here. Now we have to count the number of molecules. To calculate the number of molecules, let's use Avogadro's number. So number of molecules present in 1 mole will be, okay, 1 into 6.022 into 10 to the power 23. This is our number of molecules present in 1 mole of HNO3. If these are the number of molecules, each molecule will contribute to some particular number of electrons, because we have to calculate the negative charge. So HNO3, let's see how many electrons are contributed by which atom. Hydrogen contributes 1. Nitrogen contributes, 7 is the atomic number, so 7 electrons are present. Oxygen is 8. So 8, and how many atoms? 3. So 8 3 is a 24. 7 plus 1 8, 8 plus 24, and that is equals to 32. 32 electrons are there in each molecule of HNO3. Let me recheck. Hydrogen has 1, nitrogen has 7, and oxygen there are 3 molecules. So each molecule contributes 8 electrons. Correct? So this gives you 32 electrons. Now the number of electrons are 32. Let's calculate the total number of electrons present in these number of moles or molecules. Total electrons will be 32 into 1 into anything is 1, so 6.022 into 10 to the power 23. Now what we have counted? We have counted the total number of electrons, right? Next is, after this, let's calculate the total negative charge, because these are the electrons, not the charge. So total negative charge will be, negative charge is equals to, what is the negative charge present on single electron? 1.6 into 10 raised to minus 19, and overall this will be 32 into 6.022 into 10 to the power 23. Correct? So this will give us here, let's multiply this and check this. So 1.6 multiplied with 32 multiplied with 6.022, that is nearly 308.32, okay, into 10 to the power 23. 23 minus 19, that's 4. Okay. So this is our value. And what is the charge unit? Coulombs. So let's see if there is any such output. Yes, 3.08 into 10 to the power 6. Okay. So option C is correct for this one. They have just shifted the 2 zeros, okay, inside, and they got 3.08. Let's move to our next question, question number 3. Question 3 says the charge carried by these number of electrons we have to find. So what are the number of electrons? The number of electrons here is 25 into 10 raised to 10. Correct? And what is the charge on a single electron? 1.6 into 10 raised to minus 19 coulomb, right? So Q will be equals to simply NE. So N is how much? 25 into 10 raised to 10. E, electronic charge, is 1.6 into 10 raised to minus 19. Let's multiply 25 with 1.6. We will get 40 into, and what's the power? 10 to the power 9 and 10 to the power minus 19. Minus 9 coulomb of charge. So correct answer here is option B, 40 into 10 to the power minus 9 coulomb of charge. Let's move to question number 4. Question number 4 says if a metal sphere has initial charge of Q. So let's draw a metal sphere here. One second. Let's draw here a metal sphere. So this is our metal sphere, and what's the initial charge on it? Q. Okay, initial charge on it is Q. It's touched with another metal sphere having charge 3Q. So let's draw another metal sphere. So another metal sphere is here, and what's the charge present on it? The charge present on it is 3Q. Okay. The final charge on each sphere after they are removed from the contact. Okay, so you are touching the first one and the second one. So initially A, this is B. So if you are touching A and B, then what is the initial charge? Q, and initial charge on B is 3Q. So final charge on A will be A dash, that will be Q plus 3Q whole divided by 2. And what will be the final charge on A and B? B also, that will be B dash, that Q plus 3Q whole divided by 2. 4Q by 2, which is 2Q, and 4Q by 2, which is 2Q. So both will have final charges 2Q. Option B is correct for question number 4. Let's move to question number 5. Question 5 says if a metal sphere A has initial charge Q on it. Okay, so let's make here our initially metal sphere A. Let me call it as A here. And what is the charge here? Initial charge Q on it. It is touched to the another metal sphere B having no charge initially. So there is no charge on B. So let's draw a B here with 0 charge on it. Okay, so our B is here with no charge, 0 charge on it. Now the metal sphere B is touched to a third metallic sphere C having a charge of 3Q. So let's make a third one. This is our third sphere, and let's call it as C, and here the charge is 3Q on it. Okay, the final charge on sphere you have to find. Okay, so there is a metal sphere A, initially no charge. It is touched to another metal sphere B. So A and B are touched. So what is the new charge on A? A dash, Q plus 0 by 2, which is Q by 2. And what will be the charge on B? That will be also Q by 0 by 2, which is Q by 2. Okay, after touching B with A. Now B is touched. The question says now the metal sphere B is touched to a third metallic sphere C. Okay, so let's touch now B with C. Once you have already touched with A, it got some charge. Now with that charge, what? Q by 2 on B, you are touching C. So what will be the new charge on B dash? B double dash I'll call it, let's say. Okay, that will be the charge on B now plus the charge on C, which is 3Q whole divided by 2. Okay, and we have to find the final charge on B only. Though the final charge on C will be same as B. Okay, so this will be Q plus 2 3s are 6Q upon 2 whole divided by 2. So that will be 7Q upon 2 will go down, that will make it 4. So 7Q by 4, that will be the final charge on B as well as C. Option B. That's the correct answer for 5th one. Let's move to question number 6. If a metal sphere A, so let's draw a metal sphere. So initially this is our metal sphere. Okay, and let's call this as A. Initial charge Q on it is touched to another metal sphere B having no initial charge. Okay, so no initial charge on B. Let's draw here B. Okay, so this is our B here, no charge initially. Now a metal sphere B is touched to a third metal sphere C having charge 3Q. Okay, wait, this is similar to question number 5. So here the answer is straight away No. They are asking the final charge on A. So you have to be little careful. Situation is quite similar to the previous one, but now they are asking the final charge on A. So B, and let's draw one more sphere here. This is our C. Okay. So on C, let me call it as C. Here it is initially 0. Okay. So if a metal sphere A has initial charge of Q on it is touched to another metal sphere B having no charge initially. Okay. So if you are touching A and B, what is the new charge on A? Q plus 0 by 2. And B will also have Q plus 0 by 2. So that is the charge on A is Q by 2 and charge on B is also Q by 2. Correct? Now the metal sphere B is touching to the third metallic sphere C having charge 3Q. Final charge on A. So see here, that is the important thing. B is touching now to C. So you don't have to do anything with that. Why? Because that will not alter the charges on A. So A will still remain Q by 2 only. Okay. So you don't have to solve the remaining part. So correct answer for this is option C, Q by 2. Because they are asking the final charge on sphere A. Okay. Let's move to question number 7. A metallic sphere A has a charge of 10 coulomb on it. Okay, so let's draw here. This is our metallic sphere A. Okay, and what is the charge on it? 10 coulomb. Is touched to another metallic sphere B having a charge of minus 4 coulomb. So let's draw here. This is our B, and on this there is minus 4 coulomb. Now the metallic sphere B is touched with the third metallic sphere, okay, C having a charge of 7 coulomb. So let's draw here the third one. So this will be our 7 coulomb. Okay. Find the final charge on C. We have to find the final charge on C. Correct. So let's start with this. This is A, this is B, and let's say C. When you touch A and B together, let me recall, new charge on A will be 10 minus 4 upon 2, which is equals to 6 coulomb. What will be the final charge on B? That too will be same. Okay, when you are touching A and B. Done. Now the metallic sphere B is touching the third sphere, which is C. So what will be the new charge on B? That will be B dash. That will be, now what is the new charge on B? It's not minus 4. Be very careful. It's already changed to 6 coulombs. So 6 plus 7 whole divided by 2. And new charge on C will be also 6 plus 7 whole divided by 2. Okay, so 7 and 6, 13 by 2, and this will be 13 by 2. Okay, so this will be our, I did a small mistake here, and what was the mistake? This will become 3 coulomb. 10 minus 4 is 6 by 2, which is 3 coulomb. This is 3 coulomb. Okay, so you will put here 3, and when you divide 3 plus 7 by 2, you will get 5 coulomb. So correct answer is 5 coulomb. Be very careful with the calculations. So this is 5 coulomb for question number 7. Okay. Let's move to question number 8. A metallic sphere A has a charge of 10 coulomb on it. It is touched. So let's draw here a metallic sphere A. Okay. And it has a charge of 10 coulomb on it. It is touched to another metallic sphere B having a charge of minus 4 coulomb. So let's draw here. This is our B with minus 4 coulomb. Now the metallic sphere B is third sphere. So let's draw one more sphere here. This is our C. Okay, and this has a charge of 7 coulomb. Find the final charge on sphere A. So again, be very careful. They are asking the final charge on A. So the second part, when B is touched to C, that has no role here, because only A and B will be affected. So A dash will be equals to 10 minus 4 whole divided by 2, which is equals to 3 coulomb. Okay, and B dash will be also 10 minus 4 whole divided by 2, which is 3 coulomb. Correct answer is option C. Okay, let's move to 9th one. How many electrons would have to be removed from a silver coin to leave a positive charge of this much? Okay, so we know that if you have electrons and you remove the electrons from a particular object, okay, there will be lack of electrons, and that lack of electrons simply is positivity, right? So they are saying how many number of electrons. So you have to find n. What is the charge of an electron? 1.6 into 10 raised to minus 19, right? Coulombs. Now they are asking what? They are asking from a silver coin. So leave the positive charge. What's the positive charge? Q is given 10 to the power minus 9 sorry, not 19, 9 coulombs. So let's use our formula. Q equals to NE, and we are asked with N. So N will be Q by E. And what's Q here? 10 to the power minus 9, and that is 1.6 into 10 raised to minus 19. Correct? So when you take 1 by 1.6, okay, it will be, let's make it 10 by 16 when I remove the decimal point, okay, into 10 to the power minus 9 it is, yeah. So minus 19 goes up, minus 10 it will become, right? So 10 upon 16, let's cancel out, okay. This will give you 2 8s, 2 5s, okay. So that will give you 0. Okay, 8 6 are 48, 0.6 into 10 raised to this will become plus 10. Sorry, when minus 19 goes up, it will become plus 10. So charge, number of electrons is equals to 0.6 into 10 raised to 10. That will be our answer. Okay, this is our answer to this particular problem, which is for question 9, option B. Okay, let's move to the 10th one. An alpha particle. Okay, alpha particle is just another name to positively charged helium nuclei. Now what's helium nuclei? Our helium is the second element in the periodic table. So He2 plus. Okay, when you second element, 2 electrons, 2 protons. If you remove the outermost 2 electrons, you're left with a nuclei containing 2 protons. That is He2 plus. So option A is your alpha particle.